Hey Math One, so in this particular video, we are going to be looking at, is it a solution to the system? So we have been finding the solutions, we have been graphing to find the solution. Now we are going to look to see, is the point that is listed a representative of the solution to the systems of inequalities, okay? So first we're going to start with the graph. So the points there that we have listed are -3, 3. So I'm going to let's use a bright blue. No, let's use green because green is not in the graph. So -3, 3, we're going to go to the the x-axis, -1, -2, -3, and then go up 1, 2, 3. So right here is the point. And also let me first start by saying the solution to the system of inequalities, remember, is in the section that is overlapped, or there's an overlay, or there's two shading happening. So there, in this particular graph, we have blue shading and the red shading. And so this whole section right here is where the solution would be located. Okay, now it's inequalities, remember, so it's anything that makes that statement true. So there is a whole area that is going to have the solution to the system of inequalities, not just one point anymore, like in systems of equations. Okay, so we have -3, +3, yes, that was a solution because it shows up in both areas that are shaded. The next one, we have 4, 2. So going over 1, 2, 3, 4, 1, 2. It is on the red line. Now it is a solution to the red inequality, but it is not a solution to the systems. So this one here was a solution to the red only, and yes, it was on the line. I cannot spell only. Yes, it was on the line, but remember, if it is a solid line, it is or equal to. So it is okay for this one. So this one right here was a solution for the red only because it was or equal to. Now we have 3, 2. So going over 1, 2, 3, 1, 2. Yep, that one was only a point for the or only a solution for the red only, not the system. And then now we have a -4, 4. So negative 1, 2, 3, 4. 1, 2, 3, 4. Again, that one happens to be a solution to both of them. And here's why. So yes, it is on the red line. But remember, that one was or equal to. Okay, so this one was, I don't even know what the equation was. It starts at +3. Up 1 over 1, 2, 3, 4, it looks like. Down 1, 1, 2, 3, 4. Okay, so it looks like it's -1/4 x plus 3, and I don't know whether it's greater than or less than. I'm assuming it's less than. Yeah. Less than or equal to, because it's a solid line, so that or equal to right there is very important. -1/4 x plus 3. Okay, so it is a solution to that particular equation because it was or equal to, and it is a solution to the system because it's in that shaded section there. And then also, if you look, it's in the blue, okay, because everything above this blue line, I'm going to use blue, okay, everything above the blue line is a solution to the blue equation, and that point is above the blue line. So this one is a solution to both of them. Okay, so that's how to figure out, that is how you figure out if it is a solution to the systems of inequalities on a graph. Okay, next we're going to move on to, is it the system or a solution to the system of inequalities whenever we are looking at a math problem and solving it algebraically. Okay, so here we have y is less than 11x minus 5 and 7x minus 4y is greater than or equal to 1. So is 4, 0 a solution? Okay, so I'm going to write in blue. Maybe that's purple. I'm going to write in blue for this one. And let's do red for this one. Okay, so let's see if 4, 0 is a solution to the blue equation. So let's try 4, 0 first. Okay, this is my y value, this is my x. So 0 is less than 11 times 4 minus 5. Is 0 less than 44 minus 5? So is 0 less than 39? Yes, that is a true statement for the blue equation. Okay, now we're going to try for the red equation. okay, which again, we still have 4, 0. It's almost writing in pink, but we're going to pretend it's red. So 7 times 4 minus 4 times y, is that greater than or equal to 1? So 7 times 4 is 28 minus 0. So is 28 greater than or equal to 1? Yes, yes it is. Okay, so this one was a solution to the system, being both of them. So this was a yes. Okay, now we are going to try -0, -5. Same concept. Oh, I wish there was a way to make the eraser bigger. So 0, -5. We're going to try the same concept. So I'm going to start with the blue line first. Okay, so we're going to do 0, -5, starting with the blue line. So -5, is that less than 11 times 0 minus 5? So is -5 less than -5? No. Okay, there was not the or equal to there. It's equal to, but this did not say or equals to. Okay, so this is not a solution to the first one. So if it's not a solution to the first one and it is a solution to the second, it still doesn't mean it's a solution to the system. So we can stop here and go ahead and say no. Now, if you wanted to go the extra route and see if it was a solution to the red, you can, but because it's not a solution to one of them, it's automatically not a solution to the system because the system is both. Okay, so let's move on to 712. Okay, so we have 12 is less than 11 times 7 minus 5. So is 12 less than 77 minus 5? Is 12 less than 72? Yes, yes it is. Okay, now we're going to try what I'm calling the red equation. So we're still going to use 712. Okay, so is 12, oops, I said the red equation. Okay, is 7 times 7 less than, or minus, 4 times 12. When you get interrupted by the announcements. Okay, so 7 times 7 is 49. 4 times 12 is 48. Okay, and is all of that greater than or equal to 1? Well, 49 minus 48 is 1. And so it has the or equal to sign right there. So yes, it is greater than or equal to. Okay, we have one more to do. Oh man. This one was a yes for both, and now we're left with -1 and -3. So let's start with the blue one first. -3 is less than 11 times -1 minus 5. So is -3 less than -11 minus 5? If I do the little change there, is -3 less than -16? No. Yes. -3 and the y. 11 minus 5. -11 minus 5, -16. If I have 0 down here, -3 would be here, -16 would be all the way down here, and -3 is greater than 0. So it is not less than, so this is not true. So if it was not true for the first one, see how it's early in the morning. I just had to think through that visually. It is not true for the first one, so it would not be true for the system because remember, the system of inequalities is both of them. So again, you could try for the red one if you wanted to see if it was true for the red one as well by doing 7 times -1 minus 4 times -3 and seeing if that is greater than or equal to 1. But if it wasn't a solution for the first one, or even later if it's not a solution for the second one, it can't be a solution to the system because a system of inequalities has to be true for both. inequality. So I hope this video has helped, and best of luck on today's assignments. Remember, if you need me, I'm a private comment on Google Classroom away, or shoot me an email.